Hello, my darlings. All right, so today I'm going to make a quick recording that's going to go over the rigid transformations we've learned about. We've talked about translations, reflections, and rotations. Okay, so we're going to talk a little bit about each of these three. I'm going to go through some problems with you, and we're going to go over them together. Remember that a translation is a slide or a shift. You go left, right, up, or down. Right? A reflection is a flip over a line of reflection or an axis of symmetry. All right? And then a rotation is a turn. Okay? So let's start off by talking about rotations. So I used my concept map to help me write these rules out. So when I'm rotating 90 degrees, this is the rule that I'm going to end up following. My x and y of my original point, for my prime point, my new point, it's going to become this, negative y and x. And we'll go into a little more detail about that in just a moment. For 180 degrees, you're taking the opposite of both of your figures, both of your values rather. And then for 270 degrees, it's going to go from your original point, which is x and y, and you're going to then flip-flop them. Flip-flop your y and your x, and you're going to take the opposite of your x value. All right, so let's get started looking at our rhombus. Here's our rhombus. All right, so we've got A, B, C, D with the following vertices. I've gone ahead and planted or drawn this out for us. Certainly not perfect, but it's reasonably close. Remember, if you haven't listened to our fabulous row transformation song, this is part of it. Rotate, turn it round, translate, shift it left, right, up, or down, reflect, copy it across an axis of symmetry. All right, I'm going to be singing that over and over again, and I'm really hoping that it's going to be totally stuck in your head. All right, another thing you need to know, pre-images are in pink, images are in blue. All right, okay, so first we're going to start off by rotate, turn it round. We're going to rotate this figure, all right? So we're going to rotate it 180 degrees. I'm going to look up and see, okay, I know that when I rotate it 180 degrees, all I'm doing is I'm taking the opposite of my original values, my x and y values, and they're gonna become the opposite of what they started it from. So I'm actually going to go ahead and fill out my points first, and then I'm going to graph my figure. All right, so I know that I'm going to take 2 and 6, which is my first point. A is 2 and 6. I'm going to take my x value, which is positive 2, and I'm going to take the opposite of it, which is negative 2. And then I'm going to take the opposite of 6, which is negative 6. And that's my A prime point. Looking at B, I'm going to take 6, 7. I'm going to take the opposite of those numbers, and I get negative 6, negative 7. I'm going to do the same thing with 5, 3, and 1, 2. All right? So now I'm going to go through and I'm actually going to plot these points. So negative 2, negative 6, 1, 2, 1, 2, 3, 4, 5, 6. All right? So there's my A prime. You guys can hear Hank a little bit in the background. All right, and then we're going to look at B prime. 1, 2, 3, 4, 5, 6, and all the way down to negative 7. There's B prime. All right. C prime is negative 5, negative 3, so 1, 2, 3, 4, 5, and then down 1, 2, 3. And then finally, D prime is negative 1, negative 2. So negative 1, negative 2. All right. We rotated this 180 degrees about the origin. Okay? All right. So what we should notice is what we've done is we've taken our figure and we've just rotated it to this point. Okay? So notice where our D points are. Our A points, A and A prime, B and B prime, and C and C prime. Okay, so we actually rotated this figure. okay? All right, let's take a look next at this trapezoid here. So here are our vertices, and we're going to actually look at this. So we know we want to go 90 degrees counterclockwise. In order to do that, we're going to come in and we're going to change up our point. We're going to flip-flop our x and y values and make the y negative, or opposite. We're going to flip-flop our x and y values and make the y opposite. Okay. I know I'm going to go 90 degrees, so I know that my points need to be somewhere around here. Okay, somewhere in this quadrant. All right, so I'm going to come in and, like I did here, I'm going to do my points first. So I'm going to look at S. I've got -7, -y, or -1 rather. So I'm going to take my x value, my original x value, which was -7, and I'm going to plug that in, and that becomes my new y value. All right, so I just took this -7, which was my original x value in my S point, and I plugged it in. Now it's my y value for my S prime. All right, now I'm going to take my y value, my original y value, which was -1. I'm going to find the opposite of that, which is a +1. All right, and then we're going to take a look at our point T, which is -2, -3. I'm going to take our original x value. I'll be back in just one moment. So sorry. All right. Hank just gets so excited about math sometimes. I have to settle him down. He gets so pumped about transformations. All right, so let's come back to point T. So we're going to take our original x value, which was -2, and that becomes our new y value for a T prime. All right. Next, let's take a look at -3, our y value. Our original y value is -3. We're going to find the opposite of that, which is +3, and plug that in for our x value, the new T prime x value. All right, next, let's take a look at U, point U. We're going to take our original x value, which is -2, and we're going to plug it right in for our y value, our U prime y value. All right. Next, let's take a look at our original y value, which was -5. We're going to find the opposite of that, which would be +5, and plug that in for our x value. Finally, we're going to take a look at point V. We're going to find our original x value, which was -7. I'm going to plug it in as our y value now. It's our new V prime y value. And then we're going to take -7. We're going to find the opposite of our original y value, which is +7. All right, so these are our new points. Let's plot them. We've got 1, -7. That is now our S prime. All right, we've got 3, -2, so 1, 2, 3, -2, T prime. All right. We've got 5, -2, so 3, 4, 5, -2. There's our U prime. And finally, 7, -7, so 7 all the way down to -7. That's V prime. All right. So what you should notice here is that we have taken our shape and we've rotated it 90 degrees. So our S point, if you notice, it's rotated 90 degrees. So is our V, U, and T. Okay? We took this shape and we rotated it 90 degrees. And we did that by following this rule right here. If you are ever stuck and you're like, I just really can't remember what in the world these rules are. One thing is, first of all, you know that if it's 180 degrees, you know it's just making it opposite because it's going to be the mirror. It's going to go all the way across. So you're going 180 degrees, okay? So the two that might end up confusing you are the 90 and the 270. So the big thing to remember here is that if you're going just 90 degrees, just here, you're going to be changing your y. Okay, you're going to be making an opposite y. 90 opposite y. 90 opposite y. 90 opposite y. If you're going all the way 270, you're going to go 270 opposite x. 270 opposite x. Okay? 270 opposite x. And if you notice, just take a look at these shapes as we're looking at them, okay? As we're going through these, see if you can find any patterns with our numbers, all right? So remember, 90 opposite y, 270 opposite x. I'll write that over here. 90 opposite y, 270 opposite x. All right? And this is when we're going counterclockwise. For counterclockwise, it's 90 opposite x. I'm sorry, 90 opposite y, 270 opposite x. 90 opposite y, 270 opposite x when we're using our counterclockwise rotations. Okay? And in both of those cases, our x and y values are going to flip-flop. Okay? All right, let's take a look at our triangle for number 3. We're moving 270 degrees counterclockwise, so 270 opposite x. All right, so we're going to flip-flop our x and y's here, and we're going to have our opposite x goes here. 270 opposite x. So let's take a look. First, we're going to find our point values here, so our prime points. All right. For f, we're going to take our original y value and we're going to plug that in for our x value. We're going to take our original x value, which was -7. We're going to find the opposite of that, which is 7. We're going to move on to g. We're going to take our original y value, which was 1, and pop it right in there. We're going to take our original x value, which was -1, now becomes 1. We're going to find the opposite of that. Then we're going to come down to h. We're going to take our original y value. That now becomes our prime x value. And then we're going to look at our original x value, and we're going to find the opposite of that, which is +8. We know that we're going to be rotating 270 degrees counterclockwise. 270 degrees counterclockwise. Okay. So we want to end up in this quadrant here. We've got 90, 180, 270. 360. 90, 180, 270, 360. So if you notice, it's just a big circle is how we're thinking about this. So here we're going to start plotting our points. So we've got 8, 7. So here all the way to 8, up 7. That's our f prime. We're going to take a look at g prime, which is 1, 1. And then we're going to take a look here at h prime, which is 4, 8. So 2, 3, 4, all the way up to 8. 8 prime. Okay? I'm going to connect our dots. Here we go. All right. So we just took this figure and we rotated it 270 degrees. All right. Let's take a look at number 4. I'm going to rotate 90 degrees counterclockwise. All right, 90 degrees counterclockwise. 90 degrees opposite y. 90 degrees opposite y. So we are going to come in here and we're going to say, okay, we're going to flip-flop our x and y values. We know that. And we're going to find the opposite y value. And that now becomes our new prime x value. So 90 degree counterclockwise, opposite y. All right, so let's take a look at our points. We're going to take our original x value, which was 1, and it becomes our new y value. We're going to take our original y value, which was -3. We're going to find the opposite because this is 90 degrees. Our opposite y value becomes a +3 as our prime x value. Next, we're going to look at k. So let's start with our x value. Our original x value was 5. That becomes our new y value for k prime. We're going to look at 0. We've got to find the opposite of 0, which is just 0. So we're just going to pop that 0 in. Next, we're going to find our original x value, which was 8. I'm going to plug that in for our y value, our new L prime. I'm going to take our original y value and make it the opposite, and that becomes our new L prime x value. Now let's go to our negative 7 was our original y value. That now becomes our x value. We're going to find the opposite, which is 7. We're going to take our original x value, and it becomes our y value. Let's plug them in and see if we end up in the right spot. So 3, positive 3, 1 is our new j prime. 0, 5, 1, 2, 3, 4, 5 is our new k prime. 4, 8 is our new L prime. And 7, 4 is our new M prime. 7, 1, 2, 3, 4. All right. So we took this figure and we rotated it 90 degrees. All right. Very nice. All right, I'm going to show you the work for these other two. We're not going to actually do those together right now, but if you are following along and doing these questions, here are your answers. This is what it should look like for 180 degrees on this quadrilateral. I'm sorry, on this quadrilateral, it should look like this. And for your 270 counterclockwise, remember it's 270 opposite x. You're going to go and end up right here, and here are your point values. All right? Let's move on now to translations. All right, let's talk a little bit about translations. So a translation is a slide. All right, so we just did rotate. Rotate, turn it round, translate, shift it left, right, up, or down. Okay, so now we're going to shift it or slide it left, right, up, or down. Okay, so we're going to, one thing that we didn't talk about on our rotations, let's talk about this real quick. So what we should notice, because this is a rigid transformation, we should have the same size, same shape, new position, or different position. Okay? So with all of our rigid transformations, we should have the same size and same shape with a new position. So our image and pre-image should be the same size, the same shape, but just be in a new position. All right. This should stay true as we move on to our rotations. I'm going to write that again here. Same size, same shape, new position. A different position, okay? All right, keep that in mind because we have rigid transformations. So these should end up, the pre-image and the image, again, we're going to go with pink pre-images and blue images. All right? So we're going to translate, shift it left, right, up, or down. Here we go. All right, let's take a look at this first one, this trapezoid that we've got going on here. We see that our shift is x plus 7, y minus 9. So the easiest way you can do this through graphing, you can do this through algebra if you are more comfortable with that. I'm going to show you both ways. So you can actually just go in and say, okay, I'm going to shift my T point. I'm going to shift it 7 places to the right and 9 places down. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7 places to the left, or to the right rather, and I got that because it says x plus 7. So I'm moving along here. I'm moving my x coordinate over, positive 7, and then I'm going to go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Y minus 9. So I went 1, 2, 3, 4, 5, 6, 7 to the right, and then I went 1, 2, 3, 4, 5, 6, 7, 8, 9 down. All right? Okay. So I'm going to plot my t prime right there. All right, I'm going to go ahead and show you how you can do this with algebra. So let's take our point t, which was 0, 7. All right, that was our t point. And eventually, for our t prime, what we know we have to do is we have to say x plus 7. So I'm going to say 0, which was our x value, plus 7. And then we're going to say our y value, which in this case was 7. And I'm going to subtract 9. Okay? So this is how you would do this algebraically. You're going to end up with 7 and negative 2. So our point for t prime should be 7, negative 2. Let's check and see if that's what we got. 1, 2, 3, 4, 5, 6, 7. So positive 7, negative 2. Perfect. So you can either do it on the graph if you're a more visual learner like I am, or you can do it with math if you feel more comfortable with that. Or you can do both and double check yourself. Either way, you've got lots of good options. So for you, 1, 2, 3, 4, 5, 6, 7. And then I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, here's u prime. Okay. If all the squiggles on the graph hurt your eyes or confuse you or make you feel like, oh my goodness, that's awful. I can't do this. You don't have to use squiggles. I do because I like squiggles. But you could use pencil and erase it as you go. Or you could just move it without using the squiggles. You can also use tracing paper. If you have tracing paper, you can use it and trace your figure and just move it. It's really up to you. All right, let's go ahead and finish this. So for point V, I'm going to go 1, 2, 3, 4, 5, 6, 7 to the right. And then I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9 down. Here's V prime. All right, and then S prime 1, 2, 3, 4, 5, 6, 7 down 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my S prime. All right, I'm going to connect my dots. All right, and I should end up with the same size and the same shape in a new position, and that's what I ended up with. Let's take a look and fill in what we are missing for our points here. So S prime is going to be 1, 2, 3, 4, positive 4, 1, 2, 3, negative 3. 4, negative 3. All right. T prime we found. U prime is going to be 8, 1, 2, 3, 4, negative 5. 8, negative 5. V prime is going to be 2, negative 7. All right. Let's take a look at number 2 here. All right, so we're starting with this triangle ABC. All right, we're going to go x minus 3, so we're going to the left this time. We're going to go left 1, 2, 3. It's my x minus 3. All right, and then we're going to go y minus 4. So from that point, I'm going to go 1, 2, 3, 4. Y minus 4. All right, so my new point for A prime is right here. Okay, for C prime, I'm going to go left 1, 2, 3, and then down 1, 2, 3, 4. Here's my new C prime. Same thing for B, 1, 2, 3, and then down 1, 2, 3, 4. Got my dots. Make sure I've labeled all my points. All right. End up with the same size, same shape, different position. All right, let's name our coordinate points here. For A prime, we've got negative 3, positive 3. For B prime, we've got 1, 2, 3, positive 4, negative 1. And for C prime, we've got negative 2, 0. All right. I'm going to show you again. Here are your answers for translations for the rest of those problems. Okay. So for number 3, 4, 5, and 6, again, remember that it's same size, same shape, different position. So for 3 and 4, this is what this should look like. Here are your point values here. Okay. All right, let's go back and take a look at 5 and 6. So 5 and 6 asks us to find something a little different. So 5 and 6 is actually opposite of what we started out doing just a moment ago. So for 5 and 6, it says write a rule to describe each translation. Before, they were giving us the rule. The rule was this: x plus y, or xy, when we move it, it's going to be x plus 2, y minus 5. This was our rule. So now it's our job to find a rule. So let's take a look. We've got our pre-image is outlined in pink or highlighted in pink. And I'm going to outline our image in blue here. Let's look and see if we can write a rule. So let's use W. I'm going to go 1, 2, 3, 4 places to the left till I get to where my W point is. So that's x minus 4. And then we're going to go 1, 2, 3 places down. So that's y minus 3. So I'm proposing that my new rule is x minus 4, y minus 3. All right? Let's test it and see if that works for point y. So I'm going to go, and I can even do it the opposite way. I'm going to go ahead and go down 3, 1, 2, 3. And then I'm going to go to the left 4. 1, 2, 3, 4. Ha! Perfect! X minus 4, y minus 3. It worked out perfectly. All right? And we can test these other 2 points if we want to. We can also use this, do the algebraic method if we would like to as well. So the way we would do that is we pick point W. All right? So let's say W is 2, 3 is the original point. We want to know what W prime is, and we are suggesting that we can go in and do x minus 4, y minus 3. So let's substitute that in. We've got 2 minus 4, 3 minus 3. All right, so our W prime values should end up being negative 2, 0. Because I subtracted 2 minus 4 and got negative 2. And 3 minus 3 and got 0. All right, let's take a look at W. So I've got negative 2, 0 as my point. So you could do this algebraically or graphically, whichever way is more comfortable for you. So there's our rule for that translation. Again, I'm going to show you our answer here for number 6. For number 6, you should get x plus 1, y minus 7. All right. All right, and certainly last but not least, we're going to do our reflections. So we have done rotate, turn it round, translate, shift it left, right, up, or down, reflect, copy it across an axis of symmetry, or you can call it a line of reflection. Okay, here it is. Here's our little music. Draw a little music note there for you. All right, so let's take a look at this very first reflection we're going to do. So with reflections, what we need to know is where are we reflecting this? And this tells us we're going to reflect in the y-axis. So I'm going to take my handy-dandy Post-it notes and a highlighter, and I'm going to highlight the axis where I know I'm about to reflect over, because that helps me to keep my place. All right, so I'm going to go ahead and highlight my y-axis. When we are reflecting, we need to make sure that it's just like a mirror. So if you were going to take a look in the mirror, if you got closer to the mirror, your reflection would be closer to the mirror. If you got further away from the mirror, your reflection would go away from the mirror. All right, so here we've got our line of reflection. We're going to call this our mirror, right? So we're going to reflect this point, and this point, and this point, and this point. We're going to reflect it over this line. So I know that if C is 2 points away 2 points away from my line of symmetry or my line of reflection or my axis of symmetry, whichever you want to call it, it's all the same. I know that I'm going to have to go 2 places to the right for C prime. All right, so there's C prime. For B, I'm going to have to go 1, 2, 3, 4, 5, 6 places to the left. So for B prime, got to make sure I'm on that right Y value line right there. Okay, and I'm going to go 1, 2, 3, 4, 5, 6 places to the right for B prime. So in both cases, I'm 2 places to the left, 2 places to the right, 6 places to the left, 6 places to the right. For D, again, we're going to make sure we're using the same measure. So we've got 1, 2, 3 points to the left. So now the reflection is 1, 2, 3 points to the right. And then for E, I'm going to go all the way over to -7. Here I'm going to go to +7. E for E prime. All right. Here's my shape. Again, because this is a rigid transformation, we're looking for same size, same shape, new position. Same size, same shape, new position. Okay? Let's take a look and see what our coordinate points are for our new prime figure or our image. For B, we're going to have 6, 7 is our new point. C prime is going to be 2, 6. D prime is 3, 2. And E prime is all the way over 7, 3. All right. Let's move on to number 2. So for number 2, we've got our FGH, and this says we're going to reflect in the line y equals x. All right, hold your horses. Y equals x, that looks really crazy. All right, so it tells us that y equals x is a line, right? One way that we have talked about writing lines in this year is using slope-intercept form. Slope-intercept form is y equals mx plus b, with m being our slope right, and b being our y-intercept. Okay? With m being our slope and b being our y-intercept. If you recall, the y-intercept tells us the point at which a line crosses over the y-axis, and our slope tells us the steepness of our line, right? And we can find that using rise over run. All right, so we know that this is a line, and we know that we can write lines in slope-intercept form. So what that tells us is if we were going to take this and write it in slope-intercept form, let me just fill in the parts that we know we have. We're missing our slope and our y-intercept. We don't know what our y-intercept is. In order for this line, y equals x, to be legitimate, the only thing we need to recognize is that our y-intercept in this case is 0. When our y-intercept is 0, we don't have to write it in there because we know that it's going to go through that origin, our 0, 0 point. We also know that our slope is going to be 1 over 1, or just 1. Because again, we don't have to write it then. So y equals x is the same thing as y equals 1x plus 0. Okay? So when we go to draw this line, I know that my y-intercept is on the axis. It's at my origin. And I know that my slope is 1. So I'm going to rise and run 1. Over and over and over again. So my point, or my line, is going to go straight. It's going to cut this into 2 diagonal halves. So here I go. I'm going to draw my line of reflection here. All right. So here's my line of reflection. And remember, I figured this out because they gave me y equals x. I put that into slope-intercept form. It actually is already in slope-intercept form. But I pointed out the fact that I had my y-intercept, and I had to think about my slope here. Okay? So let's reflect this over our axis of symmetry. So again, we're going to have to be the same distance on one side for our image as we are with our pre-image. So you can, again, just kind of count. This is like half a diagonal square away. So we can do that here. I'm going to come a little closer so you can see that better. Okay? So we've got like half a square there. So we're just going to go half a square here. And that's where our h prime is going to end up. Okay? Here we go one full diagonal there on each side. There's g prime. For f, we're going to go 1, 2, 3 and a half to get to the line. So to get to our reflection, we're going to go 1/2, 1, 2, 3. All right. Again, it's the same size, same shape, new position. All right. Let's do one more of these together. Look at our trapezoid here. So it says our line of reflection is y equals 1. Again, I'm going to point out that's right here. So let me come in and I'm going to highlight it because that's what helps me to stay focused on where my line of reflection is. All right, so I see that M is, oh, we forgot to write our points up here. Let's go back and do this real quick before we come back to this one. All right, so let's write down our points for F prime. We're going to come all the way over to 8 and up 1. For G prime, we're going to go to 7, up 5. For H prime, we're going to go to 3, up 2. So that's what your points should look like for F, G, and H prime. Let's come back down here to our trapezoid. All right, so for M, we know that it's 2 points away, 2 spaces away from our line of symmetry. We're going to go 2 points the other direction for M prime. All right. For L prime, we're 1, 2, 3, 4, 5, 6 spaces away from our line of symmetry. So to get to L prime, we're going to go 6 spaces the other direction. 1, 2, 3, 4, 5, 6. That's L prime. And do the same thing with K. Again, it's 6 spaces away. All right. And J prime is 2 spaces away from our axis of symmetry. So we're going to go 1, 2 spaces the other direction to get to J prime. So in our shape, we should have the same size, same shape, new position, because this is a rigid transformation. All right, let's take a look at our points here. So J prime is going to be 1, 2, 3, -4, -1. K prime is going to be -2, -1, 2, 3, 4, 5. L prime is going to be +2, -5. And M prime is going to be +3, -1. All right. Here is what the rest of your answers will look like for your reflections. If you have any questions about these, please don't hesitate to get in touch with me or with your math teacher if I'm not your math teacher. All right, so here's what this should look like. Remember, it's okay if you want to label that x-axis, that's perfectly fine. And here are your new prime points, all right? And here's 6 and 7, or 5 and 6 rather. All right. Here's your line x equals 3 and -3. And this is y equals -x. It's just going exactly the opposite direction of our y equals equals x that we did in number 2. And here are your points that you're going to use for those. All right, that's all I have for you today. Remember that this is going to be a helpful tool for you, your rigid transformations concept map. All right. Okay, so you can find lots of interesting things that you need to know that way. Remember that you can rotate, turn it round, translate, shift it left, right, up, or down, reflect, copy it across an axis of symmetry. All right, and remember, here is your concept map for transformations in general. We're going to talk about dilations next week, so that's going to be super exciting. Here's a little sneak peek of what that's going to look like. We're also going to talk about sequences of rigid transformations. Again, super fun. And if you did happen to print off the back sides of these pages, you would have found that you could already start working on sequences. Oh my goodness. You could start working on sequences, all right? So I'm actually going to show you those answers for sequences. If you have worked on them and are interested in taking a peek to see if you have got what it takes to solve out our sequence problems already. All right? So this is what we're looking at for, this was the back page of your translations worksheet. All right? And with these, you actually are, you've got a pre-image, you're going to do a first transformation, and then you've got your prime image is in blue. So you've got your pre-image in pink, your first transformation in green, and your prime image or your image in blue. Okay? So here you've got your solutions there. This is where you should end up at the very end. Right? And here's these. Same thing here. Right? This was a little bit different. This was asking about our rules that we follow. All right, and here are your sequences. All right, I hope that this was wonderfully entertaining for you and that you now are the most confident of all people. When it comes to transformations. Please let me know if you have any questions. Here's my email address, just in case you need it. Hopefully you all know this by now. If you are not in my math class, you are still welcome to email me or email your math teacher. That is perfectly fine. I hope you guys have a wonderful rest of your day.